Hi. In this video, we are going to discuss about nucleophilicity, basicity, and leaving group, which is very essential for SN2 reactions and SN1 reactions. We are discussing. Now, first, what is the difference between nucleophilicity and basicity? Now, nucleophilicity is called as what? Electron donor, electron rich species. Basicity is also called as what? An electron donor. Both are electron donors. Then what is the dissimilarities between nucleophilicity and basicity? Now when we are taking the nucleophile, now when we are taking here aqueous KOH. In this aqueous KOH, here OH minus, what we can write here, KOH means K plus OH minus in aqueous medium. Now this OH minus is acting as a what? A nucleophile. Now this OH minus is donating the electrons to carbon, means it is called as a what? A nucleophile. Why it is donating the electrons to carbon means here carbon is what? An electron deficient center. Nucleophiles is always attacking that what? Carbon which is having that what? An electron deficient center. Because of this halogen, this carbon is having that what? An electron deficient center. So therefore the nucleophile is what? Donating the electrons to carbon, means it is called as what? A nucleophilicity or nucleophile. Next, what is meant by basicity? Now see, now here I am taking that what? An alcoholic KOH. KOH is taken in that what? An alcohol. So therefore it is called as what? An alcoholic KOH. Here the OH minus ions concentration is more. So therefore here the OH is acting as a what? OH is acting as a what? Base. Sorry. The OH minus is acting as a what? Base. Now halogen attached carbon is alpha. Now this is called as a what? Beta carbon. Now here this carbon is, this hydrogen is having that what? And partial positive charge. So therefore this OH minus is giving the electrons to H plus, means then it is called as a what? Basicity. OH minus donating the electrons to H plus. So therefore it is called as a what? Basicity. Simple. OH minus is not only OH minus, any species is donating the electrons to carbon, means that is called as a what? Nucleophile. If they are donating to H plus ions, means then it is called as a what? Base. Same way here also. Now I am taking HCN in basic medium. Here nucleophile is called as a what? Cn minus. Now this Cn minus, now carbon halogen. Halogen is the more electronegative, so therefore minus. Now this is what? Plus. So therefore this nucleophile is giving the electrons to this carbon. Whereas here, now when we are taking NaNH2. NaNH2 means NH2 is acting as a what? Base. Now oxygen, hydrogen. Now hydrogen is having partial positive, oxygen is having partial negative because more electronegative. Now this base is donating the electrons to that what? H plus. Okay, and that is difference between what? Nucleophilicity and basicity. Donating electrons to H plus means basicity. Donating electrons to carbon deficient center means that is called as a what? And nucleophilicity. Now in this video we are going to discuss about that what is a nucleophile and what is meant by nucleophilicity. We are going to discuss. Nucleophiles means they are called as what? An electron rich centers, and they are also called as what? A Lewis bases. What is meant by nucleophile means, now we discussed it. Donate the electrons to an electron deficient center, that is carbon, means it is called as what? An nucleophiles. Now carbon halogen. Halogen is the more electronegative than the carbon. So therefore carbon will get partial positive, halogen will get partial negative. So carbon is the deficient center. So therefore nucleophile is donating the electrons to this one. Next, what are the examples of these nucleophiles? All negatively charged species are nucleophiles. All negatively charged species. Cl minus, Cn minus, thiocyanide, OH minus, OR minus, SO3 minus, RCOO minus, all negatively charged species are nucleophiles because they are an electron rich centers. They can easily donate the electrons. Here negative charge indicates 2 electrons. Negative charge means 2 electrons are there. Okay, next the central atom. So now these are the neutral molecules. In the neutral molecules, if the central atom is containing that what minimum one lone pair, then they are also acting as a what a nucleophiles. Oxygen containing lone pair, sulfur containing lone pair, ammonia containing lone pair, primary amine, secondary amine containing the lone pair, tertiary amine, okay, triphenyl, trialkyl phosphorus. Next one is now this is the ether, now this is thiol, this is the alcohols. See now all these species are containing minimum one lone pair, then they are acting as what a nucleophiles. Next the compounds which are containing pi bonds also acting as what a nucleophiles, alkenes, alkynes, benzene and benzene derivatives. So now when we are taking ethylene molecule, it is containing that what pi bond. Now this is a propene molecule containing the pi bond. Now this is the benzene molecule containing the pi bond. This is the toluene molecule containing the pi bond. Now how it can donate the electrons means this is the carbon. Now these electrons will shift means here it is having the negative charge, no? So therefore it is called as what a nucleophile. Same way these electrons will shift means here negative charge is there, no? So therefore it is acting as what a nucleophilic center. Now this is. Now in this we'll see that some examples based on that what a nucleophilicity. Now here nucleophilicity is mainly depends on these factors. The species which are having less electronegative, they are having that what more nucleophilicity. Nucleophilicity is nothing but what ability of species to donate the electrons to electron deficient centers is called as what a nucleophilicity. Next, more is the resonance, less is the nucleophilicity. If the size of the nucleophile is increases, steric hindrance is operating, so therefore nucleophilicity is going to be what decreases. Next, that is inversely proportional to steric crowding. Next, we'll discuss the questions. Top to bottom, nucleophilicity is increases. Why nucleophilicity increases means top to bottom electronegativity is decreases, so therefore nucleophilicity is more. Nucleophilicity is more means it can donate the electrons easily to electron deficient centers. Next, top to bottom basicity is what decreases. Why basicity is decreases means purely the basicity is depends upon that what size. For example, I am taking that what nitrogen I am taking, or NH3 I am taking. Next PH3 I am taking. Next ASH3 arsenic hydride I am taking. Now nitrogen is the smaller size. Phosphorus is somewhat bigger size compared to nitrogen. Arsenic size is very big size when compared to phosphorus. So see now this is the nitrogen size. Now this is the phosphorus size. Now this is the arsenic size. If size of an atom is increases, dispersal of electrons is going to be what taken place. That means this nitrogen containing 5 valence electrons, 2s2, 2p3, 5 valence electrons, all are containing 5 valence electrons. But due to the increasing of size, see now that 5 valence electrons are going to be what distribute. Now here the 5 valence electrons are here, they are going to be what present. Whereas here, because of small volume, the electrons are very close. Electron density is more. Dispersal is less. Here dispersal is more. So therefore, what will be happen? This nitrogen can donate the electrons easily to that what an electron deficient centers. It is donate the electrons to an electron deficient centers. Whereas size is bigger, dispersal of electrons is more, distribution of electrons is more. So therefore, it can't donate the electrons easily to that what an electron deficient centers. So therefore, basicity is what less. Basicity depends upon the size. Top to bottom, size increases, so therefore basicity decreases. Now see now nucleophilicity and the basicity order. Left to right, nucleophilicity is what? Nucleophilicity and the basicity both are going to be what? Decreases. Now top to bottom means we have to see the size and next left to right means we have to see the electronegativity. Least left to right electronegativity is what? Decreases. Least is the electronegativity, more is the nucleophilicity. Least is the electronegativity, more is the nucleophilicity. In left to right, both nucleophilicity order and basicity order both are same. Next, when we are taking groups, now this is groups. Nitrogen family, 50A group. Now ammonia, phosphine, this. Next, top to bottom, what will be happen? I am writing nucleophilicity. Nucleophilicity, ammonia is more. Yes or no? Top to bottom, sorry. Nucleophilicity is inversely proportional to electronegativity. No? So top to bottom, nucleophilicity increases because electronegativity is what? Decreases. What about the basicity? Basicity will becoming as what? And reverse order. Okay, now basicity order is what? NH3 is greater than that what? Now when we are taking the basicity order of 50A group elements, now NH3 is greater than that what? PH3. PH3 is greater than that what? ASH3, which is greater than that what? Stibbium hydride, which is greater than that what? Bismuth hydride. Top to bottom size increases, so therefore basicity is less. Top to bottom electronegativity is less, so therefore nucleophilicity increases. Nucleophilicity increases down the group. Next, the same way, H2O, H2S, H2Ta. These are belongs to 6th group. Now from this side to this side, top to bottom, nucleophilicity increases. What about the basicity? Basicity is what? Decreases. Next, R3P, R3N. Now R3 common. Phosphorus, nitrogen, they are belongs to same group. So down the group, what will be happen? Down the group, nucleophilicity increases. Basicity is what? Decreases. Nucleophilicity increases, basicity decreases. Next, oxygen, selenium, tellurium. Now which one is having more nucleophilicity? Which one is having more nucleophilicity? Now least is the electronegativity, more is the nucleophilicity. Next, here this species is given. Which one is having that what? And more nucleophilicity? Which one is having that what? And more nucleophilicity? Here sulfur is the donor atom, oxygen is the donor atom. Here also oxygen is the donor atom. Here oxygen is the donor atom. Now compared to sulfur and oxygen, sulfur is the least electronegative compared to oxygen. So therefore least is the electronegativity, least is the electronegativity, least is the electronegativity, more is the nucleophilicity. So therefore this is having that what? More nucleophilicity than this. Next, compare this and this. Now this is having more nucleophilicity than this one because of and resonance. Here no resonance. Here there is no resonance, but here there is a resonance. I will show you. Next, this is more nucleophilicity than this one. This is having resonance, this is having resonance. This is having less resonance, this is having more resonance. How the resonance is going to be what taken place? Now for suppose, now I am taking that what? CH3, CH2, O minus. Negative charge, single bond, no resonance. When resonance is not there, the negative charge on the oxygen is remains there. Next, for suppose, now I am taking another species, that is acetate ion. Now this is the acetate ion. As an acetate ion. Now negative charge, single bond, double bond. So conjugation is there. So therefore this oxygen is giving the electrons to this one. Then these electrons will shift to this side. Always negative charge shift towards the pi bond. Now what we are going to get? We are going to get that what? And resonating structure CO minus. Then we are going to get that what? Double bond O here. Because of this resonance, so now what is the resonance hybrid? The resonance hybrid is CH3 COO. Now in this structure double bond is present here. In this structure double bond is present here. So therefore this is called as a what? And resonance hybrid. This is the resonance hybrid. Due to the resonance, the negative charge on the oxygen is what? Decreases. Because of resonance, one unit negative charge is sharing by two oxygens. So therefore negative charge on the oxygen is decreases. Whenever negative charge on the oxygen is decreases, it can't donate the electrons. That means electrons on the oxygen is decreases due to the resonance. So therefore it can't donate the electrons is easily, because number of electrons on the oxygen is what? Decreases due to resonance. So therefore resonance is there, nucleophilicity will be what? Less. So when we are comparing this and this, here there is some resonance, here there is no resonance. So therefore negative charge is more. Here negative charge is what? Less. Less is the negative charge, less is the electron density, so less is the donating capacity. Next another one is, when we are taking that what? CH3 S double bond O, S double bond O, O minus. Okay, now negative charge, single bond, double bond. So resonating structure. Conjugation is there, so it will give and resonating structures. Now these electrons will shift here, then these electrons will shift. Minus double bond O. Next negative charge, single bond, double bond. So therefore it will give another resonating structure. Now these electrons will shift, means these electrons are shift this side. Now we are going to get that what? SO minus double bond O we are going to get. Now that means this structure will give how many resonating structure? 3 resonating structures. Now what is its resonance hybrid? While in the resonance, only the pi electrons or lone pair electrons only migrating. Sigma bond electrons are not migrating, only pi electrons are migrating. So sigma bonds I written as it is. First structure, here double bond is present, here double bond is present, next here double bond is present. So therefore this is called as a what? And resonating structure. This is called as an resonance hybrid. Because of that resonance, one unit negative charge is sharing by how many oxygens? Due to the resonance, here this oxygen is carrying the charge. Due to the resonance, this oxygen is carrying the charge. First structure, here oxygen. Second structure, here oxygen. Third structure, here oxygen. Because of the resonance, one unit negative charge is sharing by 3 oxygens. So therefore it will get what? Minus 1 by 3, minus 1 by 3, minus 1 by 3. Minus 1 by 3 is nothing but what? 0.33. Here 1, here charge is 0.33. That means negative charge on the oxygen is what? Decreases or not? Negative charge is decreases. When negative charge is decreases means no electron density on the oxygen. So therefore its donating capacity is what? Very, very less. Here it is having minus 1 by 2 charge, minus 1 by 3 charge, here minus 1 charge. Here more is the electron density, more is the nucleophilicity. Here less is the electron density, less is the nucleophilicity. So that is only this one. Okay, here 2 resonating structures, here 3 resonating structures. More is the resonating structures, less is the nucleophilicity. Next another one is OH minus, CH3O minus, CH3COH2 minus, oxygen. All are having that what? Oxygen is the deficient, oxygen is the donor's center. Now which is the more nucleophilicity? Nucleophilicity is inversely proportional to what? Size of the nucleophile. When size of the nucleophile is less, see now size of the nucleophile. Size of the nucleophile is less, its donating power is what? More. See now, it is steric hindrance is less, so therefore it can donate the electrons easily. See now, here one oxygen is the donor, hydrogen. Oxygen is common, instead of hydrogen here CH3 is there, so size increases. Hydrogen size, methyl size, smaller size, it can donate the electrons easily because less steric crowding, bigger size, so less. Now compared to this is very big size. Compared to this is very big size alkyl group. Compared to this is very big size alkyl group. Because of this structure, cyclic ring, it is having that what? Somewhat more compactness, so therefore it is lesser size when compared to this one, so therefore it is more nucleophilicity. Size. See now, for suppose now I am taking that what, this is the carbon, this is the halogen. This carbon is having partial positive charge, this halogen is having negative charge. For suppose if the size of nucleophile is smaller, so therefore it can reach this carbon is easily. Reach this carbon is very easily. So therefore nucleophilicity is more. Now for suppose here some hydrogen atoms are present. Whereas if you are saying, if you are taking a bulky size nucleophile, now if you are taking a bulky size nucleophile, now this is a bulky size nucleophile, bigger size nucleophile. Now this nucleophile cannot go through this. Why cannot go through this means because it is a bigger size. This size cannot go through this. This is a smaller size, it can go through this. So attacking is here easy. But attacking of this nucleophile, this carbon is difficult because of bigger size nucleophile. Size of the nucleophile is increases. What will be happen? Its donation is what? Less. So therefore nucleophilicity will be what? Less. That is only this case reason. Next, another one. In polar protic solvents. Polar protic means which are donating the H plus ions are easily. Water, acid, carboxylic acids, dilute HCl, ammonia in water, same way alcohols. All these are polar protic solvents. In polar protic solvents, which is the better nucleophile among halogens, which is the better nucleophile? I minus is the better nucleophile, then Br minus. Br minus is the better nucleophile, then Cl minus. Cl minus is the better nucleophile, then F minus, because of the formation of what? An hydrogen bond. See now this F minus is a weaker nucleophile due to that what? An polar solvent. Why polar solvent? Now I am taking that what? Fluorine F minus. When we are using that what? An polar solvent. Polar solvent means best example is water. Now this is having what? Minus charge. Sorry, this is having minus charge. For suppose if you are taking water, molecules are like this. Oxygen, H. Now this is H plus. Now this is plus. If you are using the solvent is polar protic solvent, between this halide ion and H plus of water molecule and hydrogen bonding is exist. And hydrogen bonding is exist. Because of this hydrogen bonding, this is called as an hydrogen bonding. Because of this hydrogen bonding, this nucleophile cannot donate the electrons to this side also. This side also, and hydrogen bonding is possible. Hydrogen bonding is possible. Because of this hydrogen bonding, this nucleophile is what? Hindered. Hindered. It will be hindered. So therefore, it can't donate the electrons to that what? An electron deficient centers. It can't donate that what? An electron deficient. It can't donate the electrons to this electron deficient center. So therefore, nucleophilicity will be what? Lesser. Whereas iodide cannot form hydrogen bonding with the water molecule because bigger size, less nuclear charge. So it can't form hydrogen bonding. So therefore there is no hindered. So therefore it can easily donating the electrons. So therefore I minus is more. In polar protic solvents, because of hydrogen bonding, this fluorine cannot donate the electrons. Because of hydrogen bonding, this fluorine will be what? Fluoride ion is hindered by the water molecule, so therefore cannot donate. Whereas in the case of polar aprotic solvents, polar aprotic solvents means the solvents are polar but cannot give H plus ions. They are called as polar aprotic solvents. Now polar aprotic solvents best example is called as what? An acetone. Now CH3, C double bond O CH3. This is called as what? An acetone. Carbon oxygen, oxygen is the more electronegative, so therefore minus. This carbon is what? Plus. Now for suppose I am taking that what? One NaCl is added. NaCl is added. Now this is plus, this is minus. Now polar aprotic solvents, they can interacting with what? Only that what? Cations. They can interacting with what? Only cations. They can't interacting with what? Negative ions. Now they can't react with what? And negative ions. It can react with only cations. This oxygen can interacting with what? Only the cations. It cannot react with what? And anions. So therefore anions are what? Free ions. These anions are free ions. In these anions, which is more reactive? Fluorine is the more reactive. No? So therefore more is the reactivity. That means the fluorine is what? Can donate the electrons is easily to that what? An electron deficient centers in polar aprotic solvents. Okay. This is the nucleophilicity. Finally, nucleophilicity is what? Inversely proportional to electronegativity and inversely proportional to resonance. More is the resonance, less is the nucleophilicity. Size of nucleophile is increases, nucleophilicity also decreases. Okay, no? That is top to bottom nucleophilicity increases, left to right nucleophilicity decreases. This is the left to right. Thank you.